Cambridge Assessment Admission Testing, 6th Term Examination Paper, Step 2019, Paper 1, Section A, Pure Mathematics, Question 8. Hi, this is Babak. In this video, I'm going to solve you question number 8 of this past paper. The function f is defined for x greater than 1 by this rule. Okay, so it means that the domain of my function is the real numbers greater than 1. Part 1 of this problem, we want to show that for x greater than 2, we have this relation. Okay? Of course, it is clear that why they have mentioned x should be greater than 2, because we know that the domain of my function is the real numbers greater than 1. It means that the input for the function should be a number greater than 1. But here you see that the input is 1 over 2x, so that's not a problem if the x is greater than 2, because if x is greater than 2, x over 2 becomes greater than 1, and it is in the domain of my function, so this is defined actually. Okay, so to prove this, I prefer to start from the right-hand side and then conclude that this is equal to the left-hand side. So what is the right-hand side? It is 2 times f of 1 over 2x. Okay? So how do you calculate, for example, f of 5? So it means that because 5 is greater than 1, it is in the domain of the function. What you need to do is just simply replace x with 5. What if I ask you what is f of 0? You would say it's not defined because 0 is not in the range. What if I ask you what is f of 10? You would say because 10 is greater than 1, what I need to do is just replace x with 10. Now if I ask you what is f of 1 over 2x, you would say because of this assumption 1 over 2x is guaranteed to be greater than 1. What I need to do is just simply replace x with 1 over 2x. That's it. Okay? So what I do, I would write this 2, copy paste 2, and instead of this f, I can write the integral from 1 to x over 2, and then I will have this square root of t minus 1, the same integrand actually, t plus 1 dt. Okay? But now let us have an eye on the other side. You see the limit of this integral is not from 1 to x over 2 as I have right now. It is from 2 to x. And the relation is that each one of these limits is 2 times larger than the corresponding limit of my integral. So this motivates me to introduce a new variable which is 2 times larger than the old variable and use the substitution method to reduce this integral to a new form. Okay, so based on this explanation, you would say that, okay, let us introduce u to be 2 times this old variable t. In this case, when t, the old variable, goes from 1 to x over 2, this would imply that my new variable u, which is 2 times larger, will go from 2 to x. Okay? Okay, so then it means that this integral, so let me just copy paste this 2, and then instead of this integral going from 1 to x over 2, I run it from 2 to x. So this becomes 2 times the integral from 2 to x. But now when I change the variable, everything here, the integrand and this differential, should all of them should be written in terms of my new variable u. But that is very easy, because from here this will imply that t is 1 over 2u, and this in turn implies that dt is 1 over 2 du. Now I will replace everything here. Yes, so this becomes the integral. Instead of t, I put 1 over 2u, and then I have a negative 1. And in the denominator, I would write the same, 1 over 2u plus 1, but instead of dt, I put 1 over 2 du. Okay, so the first thing that I want to mention is that this is a multiplicative constant. I can pull this out from my integral and put it here. But then this 1 over 2 and this 2 will cancel each other, and I will get a factor of 1, which I don't write. But what I do here, I rescale this fraction by multiplying both the numerator and the denominator by a factor of 2. Then I will exactly get what I need, yes? So this becomes the integral from 2 to x, and then this becomes the square root of u minus 2 divided by u plus 2. And then I have du. And if you see, this is exactly the integral that I want to prove. I wanted to reach to that integral. So that's exactly equal to the left-hand side. Okay? Now let us go to the second part of the problem. Okay, so let us start doing the second part of the problem. I prefer to start doing this by proving a lemma for you first. Of course, I am sure that you know about it, but let me just remind you if you have forgotten. Assume that you have a function f which is integrable on the interval from a to b. So we know that the integral of f of x from a to b exists. Now assume that you shift this function along the x direction, for example by writing f of x plus c. Then we want to show that the value of this integral remains the same if you compensate this shift for the argument of the function by writing a minus c to b minus c. So what I'm saying is that if this function f of x is integrable on this interval, this new function, which I can call it g of x, is also integrable on the interval a minus c to b minus c. And not only this, but the values are also the same. Yes? Of course, you can write the same idea, but you can write the other way around. So you can write the integral of f of x dx is equal to the integral. You can subtract c, a value of c, from the argument of your integrand, provided that you add that value to both limits, upper limit and lower limit. Okay, so that is actually, from geometrical point of view, it's very clear. But let me just try to prove one of them for you, and then I will use this whenever I need it in this problem. Okay, so for example, assume that we want to prove the first one. So what can I do? I can say that I want to start from the right hand side and go to the left hand side. Okay, what I do, I introduce a new variable x. So I would say let, for example, capital X be little x plus c. Then it's clear that d of capital X is the same as dx. And we also know that here the x value goes from a minus c to b minus c. Okay, so it means that my capital X, so let me write it down. We know that in this integral on the right hand side, x goes from a minus c to b minus c. So this implies that the capital X goes from, if I put a minus c here, then I will add a c to it, so it becomes a. So x goes from a up to b for the same reason. Okay, so then it means that the right hand side of this is equal to integral from a to b f of capital X d of capital X. So you see, instead of x plus c, I plugged capital X. Instead of d of x, I plugged d capital X. And instead of having limits from a minus c to b minus c, now I have my limits from a to b. But I hope that you agree with me that this is exactly equal to the left hand side. Yes, because you know that for the value of a definite integral, the name of the variable is irrelevant. It's a dummy variable. So it doesn't matter if your integration variable is x or your variable is y or whatever else. So that's that proof, very simple proof of this idea. So from now on, I can add some value to the argument of my function, provided that I subtract the same value from both limits of the integral. Or I can subtract a value from the argument of my function, the integrand function, provided that I add the same value to the limits to compensate for that subtraction. Okay, so that's what I want to use here. It's easier. Okay, now let us see what we are supposed to evaluate here. I want to evaluate this integral in terms of f, but this time provided that x is greater than 0. Okay, but we also have this one. Okay, so let me write that in front of our eyes, or make it a little bit smaller here. Okay, I think it's still visible. Okay, so here we know this is true if my value of x is greater than 2. So it means that if x that I put here is a value greater than 2, and I divide that value by 2, this is a valid equality. Okay, what I say in this problem, let me now change my color to the main color. So here I am given that x is greater than 0. Yes, so this implies that x plus 2 is greater than 2. Okay, and then you see that this formula works if the number that I put on the here is greater than 2. So this means that from number 1 I can conclude that integral from 2 to x plus 2 square root of u minus 2 u plus 2 du is equal to 2 f of 1 over 2 times x plus 2. So what I am doing, I am replacing x here with x plus 2. But is it possible? Yes. Because this x is greater than 0, this implies that x plus 2 is greater than 2. And this formula works whenever this upper limit is a number greater than 2, provided I fit the same value for x here as well. So I have done the same thing. I have replaced x here and here with x plus 2. Okay, so that's a valid way of doing things. Okay, but now I can use this rule here. Okay, because I want to have the lower limit 0 and the upper limit x. And then you see that the difference between 2 is exactly 2. So I subtract 2 here and here, provided that everywhere that I see u, I put u plus 2. That's exactly what I proved here. Okay, so this implies that integral from 2 minus 2 to x plus 2 minus 2 square root of u plus 2 minus 2 u plus 2 plus 2 du is equal to the same value. And if you don't mind, I multiply this 1/2 inside. So then it becomes 1 over 2x plus 1. So what I am saying, you see, I copied and pasted essentially this part. And instead of this integral, I wrote this using the first part of this lemma. Okay, so then what happens? Then you immediately see that these 2 and that 2 are gone. This becomes 0. These 2 and that 2 are gone. These 2 becomes 4. So this means that I have this integral from 0 to x square root of u divided by u plus 4 du is equal to 2 f of 1 over 2 x plus 1. But this formula is valid if x is greater than 0. So let me emphasize that one as well here. If x is greater than 0. Okay, so that is the solution to the second part of this problem. Okay, and then it's good to take this one with me to the next part. Okay, okay, so I brought that formula to this page. So we know that this is equal to this expression if the input x is greater than 0. Okay, then I wanted to use the same trick for the next part of the problem. Okay, but I got stuck at some point. I will describe what's going to happen now. So I told myself that, okay, now we know that x is greater than 5, yes? In this part, x is greater than 5, but we want to write this in terms of the function f. Okay, I wanted to use the same trick, and I wanted to use this formula that I already got in part 2. This is usually the case in step problems, yes? Each part of the problem somehow depends on the previous part. Okay, so here when x is greater than 5, then it means x minus 5 is greater than 0. So here it means that x minus 5 can play the role of the input to this formula, because this formula works if this upper limit is a positive number. Okay, now x minus 5 is a positive number, so it can play the role of this x in this formula. So if I substitute x minus 5 in that formula, then I will get x minus 5 up there. Then I will have this square root sign, u divided by u plus 4, and then I have du. On the right hand side I will have 2 times f of 1 over 2 x minus 5 plus 1. Yes, this is completely right. But of course, on the right hand side I can simplify this expression. This becomes 1 over 2x minus 5 over 2 plus 1, which is 1 over 2x minus 3 over 2. So what I can replace for this is just simply 1 over 2x minus 3 over 2. And now I can use what I learned here. This time I will use this part of the problem. Yes, I can add some number to the lower limit and upper limit, provided that I subtract the same thing from the argument of my integrand to compensate for this addition. Okay, so I will use the same trick here. So what I do, by looking here what I need the lower limit to be 5, the upper limit to be x. So it motivates me to add 5 here and there, but then I need to subtract a 5 from here and write u minus 5, and I also need to subtract 5 here and write u minus 5. Okay, and then instead of this one, as I told you, I will write that simplified expression. So it becomes 5 to x, then I will have this u minus 5 plus 4 du, and on the right hand side, so let me multiply it here, it becomes 1 over 2x minus 5 over 2 plus 1. And one more step, we are close to solution but not 100% right, yes? So you see why. The numerator becomes u minus 5 as I need here. That's okay. But unfortunately, the denominator becomes u minus 1. Yes? Why? Because here I have u minus 5 plus 4, which gives me u minus 1. And then I have du. On the right hand side, I can simplify this expression, which is 1 over 2x minus 3 over 2. This is valid if x is greater than 5, of course. Even though this is a correct formula, but this is not what exactly demanded by the problem. To be honest, first I thought that it might be a misprint here, but then I realized might be I can find a linear substitution so that I can turn this into this expression to expression like this. So in principle, I was asking this question, that is it possible to have some substitution of this kind, a t, say for example b, where a and b are not known for me, but u minus 5, u minus 1 turns into t minus 5, t plus 1. Okay, so is it possible to fine-tune these two constants a and b so that after applying this transformation, this substitution, this expression turns out to be equal to this expression which I need here? Yes. Okay, so let me start see is it possible or not. Okay, here I will start from the left hand side. I will have u minus 5, u minus 1 equals to t minus 5, t plus 1. I will try to find those a and b if possible. So if this is going to work, if this is the case, then it means that at plus b minus 5 divided by at plus b minus 1 should be equal to t minus 5 divided by t plus 1 for those values of a and b. Okay, I want to compare the left hand side and right hand side. I see that these coefficients are 1, so it motivates me to divide by a if I am going to compare these two. Okay, so I divide the numerator and the denominator of the left hand side by a, so it becomes t plus b minus 5 divided by a divided by t plus b minus 1 divided by a. Sorry. And on the right hand side I will have t minus 5, t plus 1. Then I ask myself, is it possible to find a and b in such a way that this expression becomes this? If this is going to be true, this number here should be minus 5 and this number here should be 1. And this gives me a system of equations. Hopefully it will work. Okay? So I would say this implies that b minus 5 divided by a becomes minus 5, b minus 1 divided by a becomes 1. So from here what I get is b minus 5 is equal to minus 5a, and from here I realize that a is equal to b minus 1. So if I substitute, for example, instead of a I put b minus 1 here, so it becomes b minus 5 is equal to minus 5 b plus 5, and then this becomes 6b is equal to 10, and then b becomes 5 over 3. So this is the b that I was looking for. And then if I plug that b here, b minus 1 becomes 2/3, and then this becomes a. So then this means that a is 2/3. Yes? Okay, so it means that I found the transformation. I found the substitution. So the substitution is this. U is equal to 2/3 t plus 5 over 3. Okay, so my goal is to write this integral in terms of t. Okay, so u is okay, so I know that if I plug this thing here, you will see that. Let me check it again. So here I need to calculate du first. So du is 2/3 dt. Yes? Okay, but now what are the limits? For limits I need to solve an equation. Yes? So I would say that u goes from 5 to x. I want to find the limits for t. So let me just calculate t from here. Okay, so from here t becomes equal to u minus 5 over 3 divided by 2/3. Yes? So if I simplify this, then t becomes 3 over 2u minus 5 over 2. Okay? But now I know that u goes from 5 to x. Let us find the limits of t. Okay, sorry. Okay, so here u goes from 5 to x, so this implies that my t goes from, so let us calculate. If I put 5 instead of u here, then the answer becomes surprisingly 5. It's very interesting. So because you know that I don't want to change the lower limit should remain 5, so it means that I'm on the right track. If I put 5 instead of u, 3 times 5 over 2 is 15 over 2, then minus 5 over 2, it becomes 10 over 2, which is surprisingly 5. Yes, so it's very happy news, yes? So it becomes 5. But then unfortunately when I put x, something strange will happen, but I can fix it later, okay? So this upper limit is when I replace u with x. Okay? So now everything is ready. So this formula, let me make it smaller here. So this formula can be rewritten in terms of t on the left hand side. Okay? But still x is greater than 5. Yeah? So it means that the left hand side integral is now equal to integral. The lower limit is still 5, but the upper limit is 3 over 2x minus 5 over 2, and then I have this square root, okay? And then instead of u, you need to plug this. But of course you know what would be the result, but let me write it down here again. So 2 over 3t plus 5 over 3 instead of u, but minus 5. Then I have this expression, u minus 1, which becomes 2 over 3t plus 5 over 3 minus 1. And then instead of du, I have 2/3 of dt. And on the right hand side, I have still the same expression, yes? So this becomes 2 f of 1 over 2x minus 3 over 2. But still, let me emphasize that x has to be equal to 5 for this formula to work. Okay, so there is no enough space here, so if you don't mind, let me take this with me to the other side. Okay, let me, if I can fit it here. I think it's readable. Yes? Okay. Now, what can I do here now? I can simplify things a little bit. So here, you see, if I multiply the numerator and denominator by 3, this 3 is gone. So let me do the calculation here for you. We don't need to actually. Of course, we know what would be the result, but let us confirm it again, just like this, plus 5 over 3 minus 5. If I rescale it by 3, so it becomes 2t plus 5 minus 15 divided by 2t plus 5 minus 3. Yes, so it becomes 2t minus 10. The denominator becomes 2t plus 2. If I factor 2 and simplify 2, it becomes t minus 5 and then t plus 1. And that was exactly what we wanted to have. Okay? Okay, so then this 2 over 3 goes out here. So let me write it as 2/3 integral from 5 to 3 over 2x minus 5 over 2 square root of t minus 5 divided by t plus 1, and then I have dt, which is equal to 2 f of 1 over 2x minus 3 over 2, when of course x is greater than 5. This formula is working when it's greater than 5. Okay, so what I can do, I can simplify this 2 with that 2 and multiply both sides by 3. And because t is the variable for my definite integral, it's a dummy variable, so I can replace t with any variable that I like, including u itself. So then it becomes the integral from 5 to 3 over 2x minus 5 over 2 square root of u minus 5 divided by u plus 1 du is equal to 3 times f of 1 over 2x minus 3 over 2 when x is greater than 5. Okay? So this formula is valid, but unfortunately you see now that I have another problem. So everything is in order. You see, if you compare this part of this integral, that's exactly this part of this integral, but the only problem is that the upper limit, instead of x, we have this more complicated expression. But now I can replace x with something that after calculating this it becomes x. It's not hard to see that what we need to do. So what I do, I would write it as this. I will write 3 over 2, and then I would write 2 over 3x here, and then I would write 5 over 3 with positive sign, then I will have 5 over 2. So what I am saying is that I am replacing x with this expression. Okay? And again, the good point is that when x is greater than 5, because you know that this formula works if the input value x is greater than 5. Okay, but if x is greater than 5, then this expression 2 over 3x plus 5 over 3 is greater than 2 over 3 times 5 plus 5 over 3, which becomes 5 again. Okay, so I am allowed to replace this x by this expression if x is greater than 5. So everything is in order, okay? And then this becomes a square root of, you will see why this is working, u plus 1 du is equal to 3 f of 1 over 2. I have to replace that x with this expression as well. Yes, and then I have minus 3 over 2. But still this formula works if x is greater than 5. So let me repeat what I have done. I have replaced this x everywhere, here and there, by this expression. Okay? Is this a valid argument? I would say yes, because I showed you that if x is greater than 5, this expression itself is also greater than 5. So I can replace this x with that expression. But why I did this, I made a small mistake here. You see here, this was a negative sign, so this should be a negative sign. So let me clean that. Okay, this is negative. Okay, why this is good? Because now if I calculate this expression, I multiply 3 over 2 inside. 3 over 2 multiplied by 2/3, it becomes x. 3 over 2 multiplied by 5 over 3 becomes positive 5 over 3, positive 5 over 2. And then I have a negative 5 over 2 at the end here. These two will simplify each other, so I will get an x. And that's exactly what I need. So this becomes integral from 5 to x square root of u minus 5 divided by u plus 1 du is equal to 3 times f. And let me simplify this expression a little bit. If I multiply 1 over 2 inside, it becomes 1/3 x minus 5 plus 5 over 6 minus 3 over 2. But if I simplify this, the common denominator is 6, so it is 5 minus 9, which becomes minus 4 over 6. It's minus 2/3, yes? So it becomes 1 over 3x minus 2/3. So this means that the integral that I was looking for from 5 to x square root of u minus 5 u plus 1 dx is equal to 3 times f, and I can write it as x minus 2 divided by 3. Yes, if of course x is greater than 5. So that was the expression that I was looking for. Let me make it nicer. if possible. Okay, so that is a nice problem, I would say. First, I thought that might be that is a misprint, but when I look closer, I realized that we can find a first order substitution transformation so that you can change your integrand to the one that is demanded in the problem itself. Okay, hopefully it's understandable. So here I want to calculate do number 4. So the point is to write this expression this time in terms of f. Okay, so the main difference, I would say, how I thought about the problem is that when I compare this integral with these integrals, I see immediately that unfortunately I have a second power of u involved. In neither one of these I have a second power of my variable in the integrand. So this motivated me to introduce a new variable, to use a substitution, so that this is no longer is a quadratic term. Okay, that was my guide when I started to solve the problem, and then I realized that this idea will work. Okay, so the next part of the problem, part 4. First, I introduced this variable by that motivation that I explained it to you. So I assume that a u is square root of, let's say, t, if t is a positive variable. Okay, so what I did then, I got du is equal to 1 over 2 square root of t dt. Okay, and then let me call this integral I. So then what happens for I? Let us see, u goes from 1 to 2, so then it means that t goes from 1 to 4, yes? Because if u is 1, t is also equal to 1, but if u is 2, then t has to be equal to 4. So this is why when u goes from 1 to 2, t goes from 1 to 4. Okay? So then this integral can be written in terms of new variables. Instead of writing from 1 to 2, I write from 1 to 4. Okay, instead of u squared, what can I write? When u is square root of t, u squared is t itself. So wherever I see u squared, I can simply write t, and then I have square root of t plus 4. And then instead of du here, I can simply write this expression. Okay, so it becomes 1 over 2 square root of t dt. Okay, but now this first thing that I did is to take this 1 over 2 out, so then it becomes 1 over 2 integral from 1 to 4. But then I have a t here and a square root of t here, so t over square root of t is just square root of t multiplied by square root of t divided by square root of t. These are gone, so it becomes square root of t. So it means that this becomes a square root of t, and then divided by square root of t plus 4, and then I have dt. Okay. Okay, and then what can I write? I can write it as 1 over 2 integral from 1 to 4. Because t is positive, I can write this expression as t divided by t plus 4 dt. Okay, now this is completely the integrand that appeared here. Of course, the name of the variable is irrelevant for a definite integral, so this is exactly this expression. Let us see if I have it here. No, I can go to the other page, but let me here I can go to the other page and see what is going on here. So do you remember we had this formula? So let me try to bring this formula there with me. Yes. Let me put it here and make it a little bit smaller so that I can just use it here. So that was the formula that I had. Okay, so now I want to use this formula to simplify this expression. Okay, so what you see is that here the limit is 0 and the upper limit is a number, okay, a variable x. What can I do? I can write it in this form. This can be written as 1 over 2. I can split this integral into two parts. I can write it from 1 to 0, square root of t divided by t plus 4 dt, plus then I can go from 0 to 4, square root of t divided by t plus 4 dt. Okay, and then I can replace these two limits, and then I put a negative sign here, and then I would write it as the second term if you don't mind. So let me just write the integral from 0 to 4, square root of t divided by t plus 4 dt, minus integral from 0 to 1, square root of t divided by t plus 4 dt. Yes? Now if you compare this with the left hand side of this formula, so don't be distracted, you can just name it u because that's a dummy variable. So this is exactly this expression, and the only thing is that x has been replaced with 4. Okay, and this formula is valid when x is positive, which in this case is positive, and the same formula works for this one. Instead we have x equal to 1. So what I do, I just use that formula here. So this becomes 1 over 2. Instead of the first integral, I use this, and instead of x, I put 4. So then it becomes f of 1 over 2 times 4 plus 1 minus f in the second integral, I need to replace x with 1 times 1 plus 1. That's it. And then I simplify it a little bit. So this becomes integral f of 3. 4 and 2 are cancelled. This becomes 2 plus 1, 3. And then this is 1 over 2 plus 1, 3 halves. Yes, so it becomes minus f of 3 halves. So it means that the expression that I was looking for, I, is equal to 1 over 2 f of 3 minus 1 over 2 f of 3 over 2. Oh, sorry. So I made a small mistake here, because you see this integral is equal to 2 times this. So when I wrote this, there should be a factor of 2 here and a factor of 2 here, and these 2's when taken out will cancel this 2 out. So let me fix it. So there is a 2 here, there is a 2 here, and in my final answer I do not have any 2 here, and I do not have any 2 here. Okay, so let me write it properly. So final answer is I is equal to f of 3 minus f of 3 over 2. That is the correct answer for this problem. So I hope the video was helpful. The link for downloading the question papers is in the description below this video. And if you think that the video was useful, I would appreciate if you can give me a thumb up. And then for supporting me, I also appreciate if you could subscribe to my channel. Until the next video, be safe and goodbye.